Welcome back to the course Site 101X on Technology Evaluation. I'm Dan Fry, and I'm going to be focusing here on laboratory testing, in particular with a focus on suitability of products and technologies. Now, in a previous lecture, Jeff Asher discussed the consumer reports methodology, and you should have learned that laboratory testing is a very central fixture of that approach. And the reason is that laboratory testing has many important advantages. Principal among those is the fact that it is more precise and repeatable than most alternatives in most cases. Also, it can provide greater objectivity in many cases because you can describe the procedures in detail and other people can repeat those. And we can find out if there's some way that a lingering bias of the evaluator itself had an influence, or whether in fact the results are true independent of who is running the test. Now, we tend to think of lab tests in many cases as something elaborate, but they don't have to be. In many cases, they can be quite simple, as we'll see. Now, before you go into the lab and start taking measurements, it's important to be well prepared. One of the things you need to consider is what physical variables are you going to measure? Naturally, you're going to want to take some measurements on the product itself. What are its states? What characterizes its performance? But in addition to measuring things about the product, you may want to make measurements of variables in the environment as well, because those may allow you to determine what was bringing about the influence, something internal to the product or something external to the product. Now, once you have decided on something that you'll measure, you also have to decide how many times you'll measure it. That is, how many replicates you're going to make. And in order to decide how many replicates of a measurement you're going to make, you need to make an assessment of experimental error and effect size. So if a measurement changes from measurement to measurement, let's say, for example, you're studying solar lanterns and measuring brightness, it is possible that one lantern, even in the same model, is brighter than another due to manufacturing variations. So you'll have to measure multiple times. However, the number of measurements that you have to make may be small if the effect size is large. So for example, if the difference in brightness between two models is large compared to the difference in brightness between individual lanterns of the same model type, then you may only need to make a few replicates in order to make that determination. So there are power measurements that you can make that we'll discuss later on. You need to decide how many replicates you're going to take. It's also important to decide exactly how you're going to log data. Do you need to do it automatically so that you can make measurements over a long time, or is it sufficient just to write down your data in a notebook? And ultimately, regarding all of these points above, you have to document your procedures in adequate detail so that other people in principle could repeat them and see if they get the same results. Now, in many cases, what we call a laboratory test is literally run inside of a laboratory, and the reason is that we can control nuisance variables. As an example, this photograph on this slide is a picture of a solar lantern being tested for brightness indoors. And the benefit here was that we could eliminate all other sources of lighting except for the lantern, and therefore eliminate any other concerns about, let's say, light coming in from windows. This coming into the lab also allowed us to use equipment that may be delicate or sensitive so that we can use the broadest possible range of equipment. However, we can't always do our measurements inside of a lab. Sometimes we need to go elsewhere. And for example, here we see a photograph of a testing procedure. I'm going to call it a laboratory testing procedure, even though it was conducted on a roof. And the reason that we sometimes need to do this is that interaction of a product with its environment may be central. It may be the very thing that we're trying to measure. In the case of solar lanterns, that's certainly true because we need the sun's light in order to charge the device. So in some cases, what we call laboratory measurements are not actually conducted in the lab. So that's an important distinction. Now, there is an important factor that I want to bring up, and I'm going to describe this in the context of measuring durability of our solar lanterns. In some cases, the dimensionality of a space of possible states you need to be concerned with grows very quickly. And let's talk about water resistance of a solar lantern. The rain that a solar lantern might experience can vary greatly in terms of the droplet size, in terms of the velocity, in terms of the orientation of the different components, whether a cable is plugged in or not, whether a button is on or off, whether the button is actively being pressed or not. So if I begin to enumerate all these possible states, we may find that it's just too complicated to cover completely. So we want to ask the question of whether there's something we can do to accelerate the process. Would it be reasonable to run one relatively harsh test to cover a wide and complex range of relatively milder tests? In this case, we decided to immerse the lanterns in water completely and see whether they could survive that condition. And what we see is that in thinking about the ways that that test can inform the ratings, we see many in the column for water resistance in the comparative rating chart, we see many lanterns receiving the highest level of performance, outstanding. Now, many of these lanterns received that high rating because they could endure the bucket immersion test. Now, it was only the other lanterns that needed to be further tested to determine whether they were relatively average or poor by using a more complex simulation of rain conditions. So just in conclusion, let me summarize. Laboratory testing was an important part of the Consumer Reports methodology, and it has become an important part of the site methodology because of the precision and repeatability and objectivity that it can afford. However, it's also important to know when field tests are needed, and so we're going to have to describe that process of making the decision between the two. Here are some of the credits for the photos, and I want to remind you that there is an exercise for planning of laboratory tests. Please give that careful attention.